Okay, well, I'm actually here. So I apologize for missing the last 3 lectures. I hope the videos were okay. Now, I am half done producing a video for week 3 part 2, and I will get that posted later this evening. And because I'm slow getting this stuff out, the next homework, instead of being due at midnight on Thursday next week, will be due just before class on Thursday, rather than Tuesday, which is the usual. And we will have a quiz, quiz number 2 next week, but it will be on Thursday, not on Tuesday. All right, so during the last half hour of class on Thursday will be our second quiz. Are we okay with this? I shouldn't have asked it that way. Do you understand what we're going to do? Okay. Any questions at this point? Or all right. So we're going to do a review of what we've done during the first couple of weeks. If you do have questions about anything that perhaps you thought you understood something pretty well, and then you started doing the homework and realized, well, no, I guess I didn't understand that quite so well. Interrupt me, ask me questions, and we'll go through this stuff and, do this reviewing and catching up. I think. Come on, machine. There we go. All right. So we introduced the idea of comments. It's a good idea to have comments, certainly describing the major chunks of your code. You don't necessarily want to comment every single statement in your code. And a comment just goes from the pound sign to the end of the line. If you need a variable, you just give the variable's name and use an assignment to cause that variable to refer to some value. And we saw that we have values of a variety of different types. We have integers, we have strings. Well, particularly we have int, and we have stir, and we have float and bool, and then this value none. With numerical values, you can do arithmetic, and here is the whole family of arithmetic operators, and these are shown from highest precedence for the exponentiation operator down to the binary addition and subtraction operators, which are the lowest. Now, most of these operators associate from left to right, but the exponentiation operator is strange relative to the other ones, and it associates from right to left. You can, of course, use parentheses for grouping. All good? Okay. Now, in terms of the results that you get when you do arithmetic with numerical values, division always gives you back a float no matter what you're dividing. So if you divide an int by an int, you still get a float as the result. Unless the int you're dividing by is 0, in which case you get an error as your result. Okay? But division is always going to give you a float unless you foolishly divide by 0. For all of the other arithmetic operators, if both of the operands on either side of the operator are int, then the result is also going to be an int. Otherwise, the result is going to be a float. If one or the other or both is a float, it's going to be a float. Now, there's one sort of hidden exception in here, which is that exponentiation with a negative exponent is really sort of division in disguise. So if you take an integer and you use an exponent that's a negative integer, that's really the same thing as doing 1 over the integer to the positive exponent. And so you're implicitly doing a division, and you get a float as your results. Good? Okay. I already went through these low-level types, the so-called scalar data types. I just noticed that this slide says Python 3.6, but this is correct for Python 3.7 as well. And we looked at the idea of using good variable names in combination with arithmetic operations to make computations easier to understand. In the process, we also introduced the print function. When you call any function, you pass. Most functions require you to pass at least one argument. Not all functions do, but most functions require you to pass in at least one argument. And so you use parentheses and you give this list of arguments. See, now I said that word list, which is risky in Python, because no, I don't mean you're using square brackets. I mean it's, you give an argument value and a comma and another argument value and a comma and another argument value and so on. So you've got arguments separated with commas going into the function that you're calling. In the case of the print function, what the print function does is to convert each of its arguments into a human readable string and then display that argument onto the user screen. So the value of the value that the far variable is referring to here, which is 80, gets converted into a string 80, and then that string 80 gets displayed on my screen. By default, when you use a comma between arguments, the print function displays a space in there. All right, whoops. All right, I guess Adobe won't let me highlight a space, which is kind of annoying. But it's because I've got 80 comma Fahrenheit is that I have that space between the 80 and the Fahrenheit is. Okay? All right, so I've got a float displayed as a string displayed as a string, which is fairly easy to do. Then I've got my Celsius value, which is also a float, displayed as a string of characters that a person can read, and then finally Celsius displayed. We can format numbers or strings in the print function using these so-called format codes, curly brace, colon, and then either just a field width, if you want, if you're printing an integer or a string, or with a floating point number, you can specify the field width and then a dot followed by the number of digits after the decimal point that you want to see. So when I say 8.2f, what I'm saying is I want to see a total of 8 characters, which will consist of 5 digits, digit, 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 and then a dot, that counts as one of my 8, and then 2 digits after the decimal point. Okay? And those format codes are used by this format function. Any questions about this format thing? Sometimes people catch on to that pretty quick, otherwise it's confusing. Yeah?
What is 8?
I'm sorry?
8.
8 is the field width. 8 is the field width. Okay, excellent. Let me do some live examples here. Okay, so I'm going to have Fahrenheit is 80 and Celsius is, well, let me compute it. 5/9 times Fahrenheit minus 32. All right, so there's the value of the Celsius variable. The Celsius refers to that value. Now, if I just say print something like F colon Fahrenheit comma C colon Celsius, I get the F colon and then a space because of the comma, then 80, all right, and then a space and then a comma. So actually having that space there was actually not very helpful in this particular case, because I got a space between 80 and my comma. Then I've got comma C colon, which is this stuff here, and then another space because of this comma, and then finally the value of Celsius. But usually if you're reporting a temperature to somebody, you don't want to see the temperature out to 15 decimal places. Even 2 decimal places is kind of pushing it. Usually people just want to know to the degree, not to the 100th of a degree, but whatever. Now, if I say print, and then I specify a format string of F colon space with a format code of :8D, that means that I want a field containing a decimal integer, that is a base 10 integer, D for decimal, and I want that in an 8-character wide field. So 80 is going to come out looking like 6 spaces followed by 80. Okay? Then I will have, immediately following that, I'll have my comma and C colon, and then I will have another format code, curly brace colon. This time it's going to be a field 8 characters wide, but since it's a floating point value, I want to specify also how many digits after the decimal point. So I say .2. And because this is a floating point value, I say F for float. All right, so this entire thing is called my format string. This part, curly brace colon 8D, close curly, and this part, curly brace colon 8.2F, close curly, those things are called format codes within the format string. And then to make use of this format string, I say .format. Since I have two format codes, I had better supply 2 values to be printed according to those format code 40s. Format code formats. I don't know where 40 came from. It just popped out of my mouth. All right. So we're going to display the Fahrenheit temperature, which we know is an integer value, and the Celsius temperature, which we know is a floating point value. And poof, there we are. So what did we get? We got F colon space. Those are 3 literal characters that come from here, F colon space. Then we got an 8-character wide field containing a base 10 integer, and that is 1, 2, 3, 4, 5, 6 spaces and 2 digits. So there's an 8-character wide field, the last 2 characters of which are the digits 8 and 0. Okay? Then we have literal characters again, comma space C colon space. And then we have another format code. Again, this field is going to be 8 characters wide. It's going to be a floating point value with 2 digits after the decimal point. So I have 1, 2, 3 spaces and 4 digits and a decimal point to make my total of 8 characters wide for that field. Yes?
They're all by default right aligned.
They're all, I'm sorry?
They're all by default right aligned. Like if you don't put in the center or
Oh. Yes. Numbers by default are right justified in their output fields. So in this 8-character wide field, because I'm asking to display a decimal number, by default it is yeah, it's right justified. Yes, it is. I was looking at it thinking, wait a minute, from your perspective it's left. No, it's right. And likewise, so the integer is right justified, and this floating point value is also right justified. Now a string, yes? Why is it not located in the left side? It's not located in the left side because it's a number. And by default, numbers are right justified in their output fields. But I can force it to be left justified by putting I can think of this as being like a left arrow saying, all right, push everything to the left. And now these values will be left justified rather than the default, which is right justified. Strings, on the other hand, are left justified by default. So if you say something like this, print, let's see, percent 15s, percent 15d, percent 15.2f, dot format, I'm gonna make myself a rich guy here. All right, so what I want to do with this format code is to display a string 15 characters wide, then a base 10 number 15 characters wide. That's going to be my person's social security number, so it's got to be a 9-digit number. I've got 6 spaces of padding. And here is the hourly rate that this person is collecting. Oh, that would be nice. $750,000 a year, yeah. Whoops, what happened here? Oh, does anybody understand what I did wrong? I was thinking back to my C language days, and I used a C language format string instead of a Python format string. Oh well. All right, so instead of these percent signs here, I need curly brace colon. Sorry about that. I'm a very old C programmer. Several of you have commented to me that you're learning Python and Java at the same time. And it's easy to, add semicolons where you don't want them and stuff like that. All right, here we go. So now I have the string is left justified. 7. So there is my 15-character field containing a string that is left justified by default. Then I have a space because of this space. And then I have six spaces followed by 9 digits. And you can see that the integer is right justified in its output field of 15 characters. Then we have another space, and then we have 15 characters containing this floating point number, which is also right justified by default. So far, so good. If I want to change the justification of these, I could do this. I could say, okay, instead of the default for strings, which is left justifying, let's right justify the string. Just for gags, let's center the social security number, and then let's right justify the, let's left justify the hourly rate. Right. Thank you. Got my greater than symbol in the wrong side there. There we go. Okay, so now this is a 15-character wide field containing a string that's right justified. Then we have a space. Then we have a 15-character wide field. Notice there's three spaces in front, then 9 characters, then 3 spaces afterward. That's my 15-character wide field with a 9-character wide integer centered. And then here I have another space, which is this space. And then here I have a 15-character wide field with a floating point number left justified. Okay, so this does take practice. But it's a pretty consistent pattern as far as how these format codes work. The format code is always going to look like a colon, and then followed optionally by either left justify or center or right justify. That's optional. Then you'll always have a field width, which is some number. Following that, you'll have either a D for base 10 decimal integer, an S for string, or an F for float. And if you do have a float, you're allowed to ask for a couple of, you're allowed to ask for some number of digits after the decimal point. Then you need your closing curly brace. And I'm going to put that in a print so that I see something on the screen. Okay, so a centered 14-character wide field, 7 digits after the decimal point this time, and integer 8 divided by integer 3, even though those are both integers, is going to give me a float. And so there's my result. Okay, so I've got 3 spaces. Then I've got a total of 8 digits and decimal points, and then 3 more spaces afterward. Any other questions about formatting stuff? Yes?
Can you explain why integer is D?
Yes. All of this stuff originate, well, this flavor of formatting stuff in Python is derived from the C language's printf function. And in printf, you could print integer values in 3 different formats. You could print them in base 10, which is decimal, or you could print them in base 8, which is octal, or you can print them in base 16, which is hexadecimal. And so we had D and O and X as 3 different format codes for displaying integer values in 3 different number bases. Now, in Python, I think we still have those. I haven't tried this yet, but let's try this. So if I say, well, I'm not going to bother specifying a field width. I'm just going to specify base 10, base 8, base 16, and let me say 64, 64, 64. All right, well, we know that 64 in base 10 is going to be 6 followed by 4. 64 in base 8 is actually going to be a 1 in the 64's place, and then a 0 in the 8's place, and a 0 in the 1's place. So it will come out looking like 1, 0, 0. And then in hexadecimal, it will come out looking like 4, 0, because there are 4 16s in 64. Okay? So that's where the D comes from. It means base 10, decimal. In the lines of business that you folks are likely to be in, you know, we don't spend time talking about octal or hexadecimal because this may be the only time in your life that you'll ever see such a thing, all right? If you were, you know, in engineering or computer science, you would care more about this stuff. Any other questions so far? Now, I should show, by the way, that usually, again, if we're dealing with populations of people, or if we're dealing with sales information, if we're dealing with business or societal kinds of data, we typically want to see just regular floating point numbers. Sometimes you might be interested in seeing exponents. Sometimes you might be interested in seeing scientific notation. And so for scientific notation, rather than colon F, I could ask for colon E, E for exponential. All right, and so let me say 1, 2, 3, 4, 0.5678, and the same thing again, 1, 2, 3, 4, 0.5678. All right, well, as a floating point number, 1, 2, 3, 4, 0.5678 is just going to come out looking like that, 1, 2, 3, 4, 0.5678. But E says I do want to see an exponent, a base 10 exponent. And so that will print out the 1234.5678 as 1.234567 times 10 to the third. Okay, so there's what I get from %F. I had forgotten, by the way, that if you don't specify how many digits you want after the decimal point, what you get by default is 6. Okay, so I got 56780 for my float. And then for my exponent, I got 1 point and then 6 digits, 234568. E plus 03 means times 10 to the third. I saw a hand over here. Yeah.
With the 6 after the decimal point for floats format, are those reliable? That you said if you just normally look at the floats, it goes out to a set number decimal place in the last digit.
Okay, that's a really excellent question. That's a really excellent question. By default, when you use when you ask to see a floating point value with the dot format function, the default is that you'll get 6 digits after the decimal place. If you ask for, let's say, only 2 digits, notice here that I don't have to specify the field width. I'm just saying I want to float, I want 2 digits after the decimal point, and it's just going to fit in the narrowest field that it can fit in. If I ask for point 30F, well, I'm going to get 30 digits, but how many digits did I say you could rely on? Really only 15. So I'm going to get 15 good digits, and then I'm going to get 15 digits of just garbage. So I will get 30 digits, but those last 15 are going to be meaningless. And so let's do, I don't know, 14 thirds. Three times. Okay, so and the format function does do rounding as opposed to truncating. So 14 thirds by default comes out as 4 point, and then I have 6 digits, 666667. If I just ask for 2 digits after the decimal, I have 4.67. If I ask for 30 digits after the decimal point, well, the first 15 digits are good, but then I just have garbage.
The first 6 of the print are always going to be reliable.
Okay, that's a really good question. All right. A float representation on the computer is an approximation of a mathematical floating real number. All right, so a float on a computer is an approximation of a mathematical real number. And so you can't really rely on any part of what you're seeing as being meaningful unless you understand what you've asked for. We've talked about importing, We've talked about importing modules, haven't we? We've said import math as m at some point. All right, so this allows me to say things like m dot square root of 2, m dot e to the third power. All right, so there's e to the third power. And by default, all of these things are being displayed out to 15 digits. Okay, so those of you that can do trig quick in your heads, if I say, give me the cosine of m dot pi over 2. All right, so mathematically, what's the cosine of pi over 2? Any takers? Okay, so, all right, so on our circle, we've got 0, then we've got pi over 2, then we've got pi, and then we've got 3 pi over 2 and 2 pi, all right, going around the circle, the unit circle. And the cosine is the horizontal part of that. So the cosine of 0 is 1, because it's the whole horizontal line. The cosine of pi over 2, what's the horizontal part of that? 0. All right, so the horizontal part of pi over 2 is 0, but if I ask for the cosine of pi over 2, I get 6.1232339573677 times 10 to the minus 17th. How many of those digits are meaningful? None of them. All right, none of those digits are meaningful. All of those digits are garbage. This is 10 to the minus 17th power, which means that these digits start 17 digits out, so they start with garbage. So you have to have, an awareness of what numbers make sense in order to be able to decide how much precision makes sense in the values that you're computing. So floating point numbers are very dangerous because a floating point number is an approximation of a real number, and when you do arithmetic with floating point numbers, you get successively worse approximations of the real mathematical answer. When you're adding approximations and multiplying approximations and computing cosines of approximations, the approximations steadily get worse and worse and worse. So it's something to be cautious about. If you're computing statistics and you compute a sum of squares and you do a division, you're good out to 5 or 6 or 7 decimal places. But if you start going crazy doing all kinds of arithmetic, things are just going to get worse and worse. Okay, so we've flogged away at format here, which is good. Any other questions so far? Okay. I am recording all of this, by the way, so I will post this online if you want to come back and look at any of it later. Okay, so we've looked at individual scalar values, ints, floats, bools, strs, and none. We can create a list of values by enclosing values in square brackets separated with commas. And we've seen that you can use integer subscripts in square brackets to access or look up individual items within the list. You can use negative subscripts if you want to count back from the end of the list. Okay, so this is a list of 4 items, which means that m sub 3 is the last item in the list. And m sub 3 is the same item as m sub minus 1. Okay, 4 items in the list. I can look at them as sub 0, 1, 2, or 3, or I can look at them as sub minus 1, minus 2, minus 3, minus 4. I can also request slices from a list by using the colon notation. And the first part of the slice specifies where you want to start from. So here I'm starting from item sub 1, which is actually the second item. And the second index is the index that's one beyond the end of my slice. So when I say, give me a slice from item 1 up to but not including item sub minus 1, that's going to give me from item sub 1 up to but not including the 0 that's at the end of the list. And so what I get as my slice is a list containing the minus 3 and 5. Yeah?
If you have a multi-dimensional list, how would you reference an item on the second row of that?
Excellent question. You can create lists of lists, or lists of tuples, or tuples of lists. So I can say something like this: M2 gets square bracket, 1, 2, 3, 4, close bracket, 4, 3, 6, 7. This is a list of lists. I can think of it as a two-dimensional list, in effect. M2 sub 0. Let's see. List sub 0 is going to be the initial item in that list. The initial item in M2 is a list. So the initial item in M2 is the list 1, 2, 3, 4. Because M2 sub 0 is a list, if I want an item from that list, I can say M2 sub 0 to get that list, and then sub, let's say, 2 to get the sub 2 item from that list. Okay? So M2 sub 0 is a list of 4 items. M2 sub 0 sub 2 is the sub 2 item in that list, and that's going to be the 3. Good? More questions? Other questions? Okay. We talked about using star, meaning repetition, plus, meaning concatenation. We can modify an individual item in a list by using M with a subscript on the left side of an assignment. And then there are a whole bunch of named operations like sort and insert and append and reverse and so on. Yes?
Yeah, I guess you might be getting to this, so stop me if you are. But just reviewing the homework that's due in a week, we're going to be essentially loading data into a list, right?
Have I posted homework 3?
Yeah.
Okay, good for me.
Yeah. So I wonder how you would recommend we go about doing that. Do we just insert the document into the list?
Well, okay, so if it's in homework 3, I assume that we will, during the lecture today and this evening, provide enough information for you to be able to do that.
Okay, perfect.
Let's wait a little bit. Maybe later on in this lecture, if it doesn't look like I'm getting there, you can ask me again. Other questions? Okay. All right, so we've got append, we've got insert, we've got clear, we've got count, on and on. A list is one example of what's called an iterable. An iterable is a whole category of things that you can step through sequentially, item sub 0, item sub 1, item sub 2, and so on. A list is one such example. A stir is another such example. And the range function is an example of an iterable. We can use the for loop to step through the items in any iterable that we want to. And so in this first example, the variable I, and we just picked this variable name out of thin air. I could have called it zebra or XYZ or whatever. That variable I is first going to take on the value 1, and so I'm going to print out 1 squared on a line, because print automatically gives me a new line. Then I will take on the value 5, and so I'll get 5 squared, and then 9 squared on the third line, minus 4 squared, and finally 12 squared on the 5th line. I pick numbers that I can actually square in my head, but whatever. Okay, greeting is an iterable, and when you iterate through it using a list, using a loop, using a for loop, what you get is the one character wide substrings from that string. So when I say for s in greeting, well, the first time through the loop, s is going to be referring to the little h. And then s will be referring to little e, and then little l, and then a second little l, and then o. So this loop is going to go through 5 times, printing out h, e, l, l, o on 5 separate lines. The range function, if you give just one argument, says how many total values you want, and you get back, like if you said range 5, you get back 0, 1, 2, 3, 4. You get back 5 values, but not including 5 itself. Okay, the counting starts from 0. But if you specify 2 arguments, as I've done here, then the first argument is treated as the initial value, and the second argument is treated as 1 past the final value. All right, so 5 comma 10 gives me 5, 6, 7, 8, 9. And just as a reminder, if you want things on a single line instead of on separate lines, you can use this keyword argument end to say that you want the end of each print statement to just have a space on the end instead of a new line on the end, which is what you get by default. By the way, if you wanted to double space things intentionally, you could say something like this, for x in range 4, print x and equals new line. All right, so it's fine to have 2 new lines at the end of each print if you want. You can have any string that you like as your end value. Happy with for loops and iterables? Okay. We also have another form of loop called the while loop. Frankly, the while loop is much less commonly used than the for loop. But, here's an example. You have some Boolean expression that's evaluated. If that Boolean expression is true, then you perform whatever's in the body of the loop. And when you're done executing the body of the loop, you come back up and you evaluate that test expression again. And this will just keep looping and looping and looping until eventually you hope that that test expression becomes false, and that will kick you out of the loop. Even if you are a quite experienced programmer, it's remarkably easy to mess up a while loop because you, first of all, you have to remember usually to initialize some kind of looping variable before you get to the loop. And then you also have to remember to either increase or decrease or in some other way change that looping variable at the bottom of the loop. And if you forget either the initialization part or the change part, it's very likely that you're going to create an infinite loop that just runs forever. So I prefer to avoid these and use for loops mostly. To evaluate expressions to get these Boolean results of true or false, we have this whole collection of equality and inequality, relational, identity, comparison operators, and we also have the logical operators, not, and or. All right, and we can combine these together in various ways. Now, for those of you that are currently learning Java, or for those of you that already know something about C or C++, this precedence hierarchy is painful because it's quite different from these other languages. First of all, in most of those other languages, not has the highest precedence, and here not actually has lower precedence than all the equality and relational operators. Likewise, I believe it's true in Java that the relational operators, less than or equal, greater than or equal, those have higher precedence than is equal and is not equal, correct? I thought I saw someone blink. Do they not? We're not sure. Okay. I'm being stupid here, right? Java relational operator precedence. Yeah, as I thought. Okay, so let me grow this font. But as I was sure, in Java, notice that less than or equal, greater than or equal, do have higher precedence than the equality test and the is not equal test. Where's not? Not, which is just just the exclamation mark in Java, has very high precedence, whereas and or, which are the double ampersand and the double vertical bar, have low precedence. So in Java, the precedence rules are very different from what there are in Python, and so this will, if you're trying to learn both at the same time, cause you a lot of grief. Okay? Isn't that fun to know? All right. In addition to using Boolean expressions to control while loops, more commonly we use them to control these if, else kinds of decisions. And in a decision, if you want to have a decision, then you must have one and only one if. All right? The if is the required part when you want to make a decision. Optionally, you can have, following the if, any number, including 0, of elif parts. And at the bottom of the whole thing, if you want, you can have at most one else statement. So it's fairly common to just say, if something is true, do something, and that's it. Or you might say, if something is true, do something, otherwise do something else. That's also really common. But if you have a multi-way branching decision to worry about, then you may have a whole bunch of elifs in between. So if the first thing is true, do the first statement. Else if the second thing is true, do the second statement. Else if the third thing is true, do the third statement. Blah, 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 blah. Else do some default thing if none of the if or elif decisions were true. Good? All right, we took a look at getting input from the user using the input function. Usually input is provided with a prompt to display. We also looked at conversions. So when you ask the user for input, you always get a string back from the user. But sometimes you want that string you got back from the user to be treated as a number that you can do arithmetic with. And then you have to do a conversion. Yeah?
Do you need to put the else on the bottom, or could you go use elif?
Excellent question. The else does have to be at the bottom if you have one. So you can't say if, else, elif. If you try to say if, else, elif, Python will get to the elif and will yell at you, hey, you don't have an if for that elif.
What if I just say elif all the way down and end with an elif?
That's fine. You got to have an if at the top.
Right.
But then you can have as many elifs as you want, and you don't have to have an else at the bottom. Yes?
On a similar note, is it possible, Python won't recognize elif if is true. Does that make sense? Like, you can't have two statements be true after that. Is that correct?
That's exactly correct. So let's suppose I said this. J gets 200. And then I say if J equals 200, print 200, elif j mod 10 equals 0, print divisible by 10. Okay, both of these tests are true. J is equal to 200. J is also evenly divisible by 10, so j mod 10 is 0. But only the if part will be performed, because elif specifies something to test if the first test didn't succeed. So what you do if you have a situation like that, if you want to test multiple things and you want to force all of those tests to occur, you just do multiple ifs. You say if j is equal to 200, print 200. If j mod 10 is 0, print divisible by 10. Here I'm doing it interactively, so it looks kind of stupid, but if I had a program file, and then I would just have, these two lines of code immediately followed by these two lines of code, and then I could continue saying, well, if this is true, do this. If this is true, do this. If this is true, do this. And I can have a whole sequence of just plain ifs. Other questions? Okay. All right, so if you do need to take a string and convert it into an int, you use the int conversion function. Here we're showing examples of converting floats or booleans to int, but I could just as well say, I can't say something like this, 123, go away, 123 times 4, right? I can't do that. String times string is not defined. But I can convert the string 123 to an int and multiply that by the string 4 converted to an int, which will give me the int 492. If I require that thing to, in turn, to be a string, well, I can say string of all this stuff. All right, and so I've converted my two strings to ints, I've multiplied the ints together, and I've converted the result back to a string. Okay? Dealing with users in particular, but also just dealing with data files or any other unexpected occurrences. It's common for exceptions to be raised, and so you can use this style of coding to say, well, I'm going to try to execute some statements and I'm going to hope that they work, but if they don't work and one of them throws an exception, let me capture that exception down in this except block and try to do something to clean up the exception. Okay, so with all those little pieces, with scalars, lists, uh-oh. I've been watching Fringe lately. Have any of you ever watched Fringe, where there's an alternate universe with mostly the same people, but they behave slightly differently? And I think I'm getting myself confused between what I'm talking about now and what I recorded this morning. So let me back up really hastily here. Okay, we talked about lists, but we don't know about sets yet, right? Okay, good. Okay, but we do know enough now. We know about scalar values, variables. We know about lists. We know about arithmetic, relational tests, logic, we know about loops, we know about decisions. So we know a lot, and we can actually start doing programming. And when you're doing programming initially, anytime you're writing a small program, that almost always consists of just 3 parts. You read some input from somewhere, you process that input in some fashion by doing something as simple as reformatting it, or doing something more complicated like converting things to numbers and doing computations. And whatever processing you do, you then have to produce some kind of output that somebody can read and use to, either become better informed or actually make some kind of decision. And so here is an example of a program that we looked at, this user age thing, that asks the user for some input, processes the input by checking to make sure that the input is in some appropriate range, and then displaying some output to confirm to the user what their age is once they eventually get around to typing a valid age value. Okay, so even using just the amount of stuff that we know now, we can start writing code that does useful things. All right? Yes?
Can you show the code again?
Yeah.
So why do you set the age to 0 in the second line, and then again to -1 in the eighth line?
That's a good question. That's a good question. Why do I set age equal to 0 up here, and then down here set it to -1? This line up here, whoops. This line up at the top where I'm saying age gets 0, in Python that isn't really necessary. I can just leave that out. But I am accustomed to, if I'm using a variable inside of some code, like inside of a loop or inside of a decision, I'm in the habit of specifying some default value for that variable before the decision of the loop even starts. In most languages, that's required. In Python, it's optional. So I could have left that out. Now, the reason that I said age gets -1 down, the reason I said age gets -1 down here is because I want to make sure that the age variable exists and that the age is not a valid value when I come down to the next thing, which is to make a decision about whether age is in the correct range. I want that Boolean to be, well, I guess I'm doing not of it. So I want the age not to be in the correct range so that I do show the user this message saying enter a value greater than 0 and less than or equal to 125. Yes?
You could just get rid of the age equals 0.0 before the while loop.
I could. Right.
And if you got rid of
That would make me feel like I hadn't shaved before I left the house, which I didn't, but you can't tell. Yeah, other questions?
if you got rid of the -1, then how would it affect?
If I got rid of the -1, if this float conversion fails, then the age variable might not even be created. And so when I get down here to comparing whether age is greater than 0 and less than or equal to 125, I'd get an error saying age. I never heard of this thing called age. Okay?
Wouldn't that be created by the input?
No, what's created by the input is this age string. Okay, so what's created by the input is this age string variable. Now the age string variable for sure is going to be created unless the user does something like pressing Control-C to kill the program totally. But what can fail, and what will throw an exception or raise an exception, is converting the age string into a float. That may fail. You know, if the user types as input FIVE, then converting FIVE to float is going to fail. Float isn't smart enough to know how to do that conversion. And If float fails, age might not get created at all. So what are my choices? Well, I could look through reams of Python documentation to find out exactly what happens when the conversion fails, whether the variable gets created or not. But I'm much too lazy to read all of that documentation. And I also know that Python changes in subtle and annoying ways about every 6 months. So I'm protecting myself, and I'm saying, I don't know what's going to happen with age here, so I'm going to create one and assign a bogus value to it. All right? Good? All right, we looked at defining functions. Here we had this F to C, Fahrenheit to Celsius conversion functions. We use the def keyword to start out the function definition. This particular function takes just one parameter and uses that to perform a calculation which then returns the result. And functions are sort of the basic unit of decomposition in what's called top-down programming. When you're doing what's called top-down programming, all right, I already told you that simple programs consist of getting input from somewhere, doing some processing, and producing some output. That's basically what happens. Now, each of those three steps can be further broken down into other steps, like, all right, get input from somewhere. Okay, that means I'm going to open a file. I'm going to use a loop to read the lines of the file. I'm going to put those lines into a list after I have chopped the new lines off from each line. I've got a sequence of steps involved in just getting the input. In what I just described, all of those steps are built into the language. I have built-in facilities in Python that will let me get rid of the new lines, create a loop, create a list. But I might encounter one step in getting my input that's not just something that's built into Python. What do? Well, I write a function. I write a function that will handle that problem by breaking that problem down into even smaller steps. All right, so you start with 3 steps: input, process, output. You break the input down into steps, which may require you to write some functions. You break the processing down into steps, which may require you to write some functions. And you break the output down into steps, which may require you to write some functions. And in fact, as your programs get bigger and bigger, processing may get to be really big and nasty and complicated. So you may have to break processing down into like 4 major steps, and you can write a function for each one of those major steps, and within each of those functions, break it down into smaller and smaller and smaller steps until eventually, by breaking things down into functions in this top-down way, you get down to simple problems that you can directly solve using the built-in facilities. Did you believe me? Okay. An enormous amount of software is written that way, especially software that's for doing data analysis where you've got just 1 or 2 programmers involved, and your problem is as simple as getting a bunch of data, analyzing the data in some useful way, and producing some output, whether it's a table of numbers or a graph or something like this. Beyond this functional decomposition, beyond this top-down programming, if you're dealing with really massive systems with lots of programmers involved, software that may last for years and be modified many, many, many times, you have to get beyond this top-down approach and enter the world of object-oriented programming, which you're probably being assaulted with in Java, those of you that are taking Java. Okay, but we don't need all of that. We don't need all of those bazookas and machine guns for doing full-blown object-oriented programming in here. All right, so here's another example of a function that I'm using to illustrate the idea of top-down programming. I'm writing a really simple function here called min of 2 that takes 2 arguments and returns the minimum value of the 2 arguments. Okay, so if a is less than b, I'll return a, otherwise I'll return b. Now, what if I want a function called min of 3? Well, I can write that completely separately. I'm getting 3 values, a, b, and c, and I can compare a to b, and a to c, and b to c, and rank them and figure out which one is the minimum and return some value. Or I can just recognize that, oh, I've already got min of 2, which will tell me the minimum of a and b, and clearly the minimum of a and b compared with c has to be the minimum of a, b, and c. So, so I've implemented my min of 3 function by calling min of 2 twice. And this is kind of the core idea of software reuse where functions are concerned. Okay, we took a look at dealing with files using with open. Question?
I was just missing it, but how would C be returned in the last one? C was
Let's try this out. Let me type these guys in. Define min of 2, a, b. If a is less than b, then the minimum is a, correct? Else, the minimum... I don't know why, but I always remember my colon at the end of def and at the end of if, and never after else. I never remember that one. Else, colon, return b. So there's my min of 2 function, and I can test it. Min of 2, 5, 7.9. Min of 2. Okay. Now to define min of 3, a, b, c. Well, if I discover what the minimum of a and b is, then I can compare the minimum of a and b with c to return the minimum of a and b and c. So I will return, let me write this out longer. Let me say min of a and b gets min of 2 a, b, and then return min of 2 min of a and b, c. You believe me that that should work? And it does. Min of 3, 1, 5, 3. Min of 3, 123, 219. You know, it's going to work. And all I did in my implementation here on slide 22 was to eliminate this min of a and b variable and just return the min of 2 of the min of 2ab with c. Okay? Here, by the way, those of you that are still trying to wrap up, I think it's, what, part 2b and part 2c or something of today's homework. Here's good hints about how to, open a file, get the lines from the file one line at a time. Each line is going to end with a new line, but you can use the slice idea to get rid of that new line, saying, all right, this line has a new line at the end of it, so I want the line up to but not including the new line. And then we're splitting that line into a list In your case, you're going to need to use split on colons instead of split on columns, on commas. And then you can analyze the values of the columns of the fields within the list in any way that you like. Here are some special characters that you will find in strings. These are actually individual characters, but you have to represent them as two characters. All right, because there's no single key on the keyboard that represents a new line character. So in a string, we represent that as \n. Likewise, there's no single character on the keyboard for a tab, so we use \t. Okay, and then finally we took a look at modules. So that is a review of stuff we looked at over the last couple of weeks. Does anybody have any remaining questions, particularly about the homework that's due this evening? I invite your questions. Yeah.
So this is in particular where we have to do the formatting.
Okay.
And it has to do the formatting with the numbers compared to the header. How do we do that? So the header will be in string value, but all the numbers are going to be numbered.
Okay, excellent. So you're talking about the expenses file where you've got the header, which is strings, amount, category, date, description, right? And then following that, you've got a whole bunch of records that have dollar amounts, category, date, and description. So let's take a look at that. Let me get the appropriate file. I hope I already have it. No. Hey. There we go. There's my expenses file. Good. So I'll get into here. All right, so here is my expenses file. And, all right, so it starts out with amount, category, date, description as the header line, and then we have values for the individual lines. And I can use the code that we just looked at here, basically. I can use this code, more or less. So let me create a program file. New file, and I'm just going to call this thing HW2 example.py. And the first thing I want to do is I want to say fn is open. Come on. Expenses.text for reading text, where the encoding is ASCII, which is the same as just saying UTF-8. And then for line in FIN, let's start by just printing the line. Good? We're just going to start by printing the line. And as we've already seen, and I also better remember to close my input file. Let me save this as HW2 example, and I'll run it. And it worked. And it displayed the lines double-spaced because we know there's a new line character at the end of each line of input, and print itself adds another new line at the end of what it displays as output. So this is why we want to do our step of getting rid of that new line, saying, all right, instead of the entire input line, I really just want the part up to, but not including that last character. Good? All right, so now I got rid of the space. And what we're asking you to do, let's see, we need to split each one of these lines up at the colons so that we have a list of the fields in each of the lines. So let's, I'll call this fields, gets line.split at colons. And then instead of saying print the line, I'm going to say print fields sub 0, fields sub 1, fields sub 2. You'll notice that there isn't any part of the homework that asks you to do anything with the description. I could have been cruel and made you look at the descriptions as well, but I'm only making you look at the dates and the categories. So I'm not even going to print fields sub 3. I'm just going to do this part, okay? Hello. F5. And there we go. So my print statement printed out for each one of these lines, field sub 0, field sub 1, field sub 2. And I'm just ignoring the description, field sub 3. But now you're asking, how do I separate the header line from all the other lines? What do I know about where the header line is? It's the first line, right? So I can use the fact that it's the first line to separate it that way, which means I can say got header is false. I haven't got the header yet. I've read a line. I've split the thing up, and now I can say if not got header, header equals fields got header equals true. If got header, or then I can say print header header. Else, does that make sense? All right, so I start out with this flag saying, have I got the header? No. Got header is false. I read a line. Well, I know that the very first line I read is the header. So my test here is immediately going to be true. Not got header is going to be true. So I'm going to save the header. I'm going to say, all right, I got the header now. And I will print the header. After I have got the header, which is the first line, I'll just print the first three fields of all the subsequent lines. Does that seem fair? So let's run this now. And why doesn't it like me? Invalid syntax. What did I do? I'm sure all of you answered my question, but I I forgot the colon. Every time, I tell you.
But also false is
Oh, false is incorrect too, yeah. Yeah, so that's, yeah. So in C++, probably Java as well, true and false are lowercase, is that correct? For sure it's true in C and C++. Anyway. So I have the same problem if you're learning multiple languages. Okay, so there's the header. I've saved the header in a list that contains the strings, amount, category, date, description, and anything that's not the header is a data line. Should I take it further?
Yeah.
Any questions? Any other questions? More questions? Yes.
Going back to the for loop,
Yeah.
for the initial two statements, why does it have to, like, why do you need line equals line minus the last character? Why can't you just do line without that character?
Dot split without
Yeah.
the...
Or even dot split, yeah.
Well, it's because when I get the line in, it's going to have all of the characters that I think of as being information. But at the end, it's also going to have this new line character stuck on the end. And I just don't want to deal with that new line character. I want that new line character to be gone. So when I split the line, I don't have to think, okay, I've got 1, 2, 3, 0, 1, 2 fields with just strings. And then that fourth field, it's still got that new line hanging around on the end. So at some point, I'm going to have to get rid of that new line character in order to have my output be sensible. Let me show you a really simple example. I'm going to save this as y no new line. And what I'll do is I'll say I'm going to not take the new line away. I'm going to comment that out. I'm going to split up into fields, and I'm going to say, well, I don't like having the amount and then the category and then the date and the description. I want to have the description and then the category and then the date and then the amount. I want to change the order in which these things are displayed. So I want to take the input and basically take the first field and put it last, and the last field and put it first. So I have the description, the category that expense belongs to, the date when the expense occurred, and then the amount at the end. Seem reasonable? Okay, so now let me show what happens. Well, that looks pretty nasty. Because I have my description and then my category, date, and amount is on the next line down. And that's because this new line character that was in the input file is part of that sub 3 field. So it drops down to the next line.
Yeah, okay. I got that. I think the thing I was having trouble with is when the reference line equals line.
Oh, in other words, why do I say line gets line whatever?
Yeah.
Why don't I just say that?
Yeah, exactly.
Okay, excellent question. This notation, line sub and then colon -1, gets a slice, but then the slice just sort of disappears into thin air. I need to have a variable to refer to that slice that I just got. And I could have said foo gets, I could have created a variable called foo and then split the variable foo instead. But since I really don't care about the original line, I only care about the line with the new line character gone, I can just say, all right, let's just reset line, let's just change line to refer to this slice from the original line.
Okay.
All right?
Yeah.
Because once I've gotten rid of that new line character at the end, I never want to see that new line character again ever. So I'm just changing line to refer to this modified subset of the line. Okay?
Yeah, thank you.
I don't know if we're going to get kicked out at any moment here. I'm happy to stick around, but we'll probably get kicked out. Any other questions? All right. So I will be in my office for another hour and a half. And so if you do have questions, you're welcome to drop by.